Hello everyone, I'm going to use this particular video to talk about IRC Senior League 2015's solution. Firstly, I've tried to structure this particular video in four different parts. Firstly, I'm going to talk about the problem statement. Then I'll give a little bit overview of what is the mechanical design I am thinking. Then what are the softwares required, and finally the actual logic. So let's just walk through the problem statement once. As you can see on the screen here, this is what the problem statement looks like. So your mom bot has to start from the earth. It has to go forward. On the left hand side, the first black strip that it encounters on its left hand side is national flag. It has to pick it up, go all the way, get some points by completing orbit 1 here, go all the way, pick up some radioactive broadside debris on the second black patch, then go all the way and complete the slingshot path 2, the orbit of slingshot path 2, then further go all the way onto the next black strip and drop the radioactive debris in the drop area. So be careful, this has to be dropped into the area which is earmarked specifically. If it is done partially, then partial points will be given. So further, then complete the next orbit here, orbit 3, go all the way into the Mars gravitational field, where the color scheme changes, a white line on a black surface unlike the black line on a white surface, and finally go all the way up till the end and stop there and drop the national flag, or the hoist the national flag. So that's a problem statement. So the way I've tried to solve this problem statement is, in this particular solution, I'm not going to come up with the solution for dropping and picking up the different props on the arena, but I have written just a solution, a hint solution for completing the whole line follower. Firstly, it should be able to follow a black line on top of a white surface, and secondly, once it comes into the Mars gravitational field, it should be able to follow a white line on top of the black surface. So let's see how the solution looks like. Even before we go there, let me just the second thing I want to kind of talk about is what is the mechanical design. But before that, let me just talk about the softwares which are required for this. So for this, you have to go to avishkarbox.com/software. You have to download RoboG 2.1. This is the one which is capable of solving the problem statement for this particular for this particular robot. You can of course do it on 2.0 as well. This particular software is workable on Windows 10, 8.1, 8 and Windows 7. There's an installation video which is already mentioned here. You can use its help as well. So once you have downloaded and installed the software, the next thing is, let's make a robot design. So I've created a small sketch of what your design should look like. On my particular program is based on that. So if let's assume this is the robot, the bottom right hand side or the rear motor is M1, which is connected to port 1. The rear left hand side motor is connected to M2, which is port 2, and the top sensor S2, the top front sensor is S2 and top left sensor is S1. So keeping this in mind, whatever the logic I've written makes sense. Okay, now let's talk about the actual logic. So let's open up the software. So you'll have to open up RoboG 2.1. I'll write few functions and I'll write some code. So the goal is again repeating the solution of the problem statement all the way up till the first three counts of this black patch. So I'm writing the logic where I'm using two sensors which are on the Earth's, or rather up till Earth's orbit. It is going to follow the black line, and once it reaches Mars gravitational field, it is going to follow the white line. So here essentially up till this point I have to create a black line follower, and after that I have to create a white line follower. So that's what I've done, or that's what I intend to do. So let's go to the program, let's start it quickly. And since I have to count these particular black stripes, 1, 2nd and 3rd, before I actually, on the 4th one I will change. So I'm going to use a counter as well. Go to the variable and create a variable, call it counter. By default give it value 0, declare, and drag and drop this. So I have a counter here. Now we will do it on a loop, or we'll do have a infinite loop. So comparison should be, of course, 1 double equals 1. Don't forget to have the operator as well and compare. Now whatever is, whenever this loop is true, which is always the case, it will go forward in this direction. So now what I'll do is I'll read sensors. So I am going to read the sensor S1 and sensor S2. The first condition is, let's look at the robot again. The first condition would be, let's assume our thing is going to follow um, a black line, right, as you can see over here. So if it is kept here, S1 is pointing at this direction, S2 is pointing over here. So ideally, firstly your robot should, your sensor S1 should encounter a black line, and then and by that time, sensor S2 should be pointing at a white surface. So there are four cases: either S1 and S2 both are pointing at white, in which case I would, for example, the initial cases, I would want the robot to go forward. If it points on a black surface, S1 points on a black surface and S2 points on a white surface, then in that case I would want the robot to take a left turn, otherwise a right turn. And if it's on the both, if both the sensor 1 and sensor 2 are in black, those are essentially going to give me a hint whether these black patches are there. So just, I mean, anyone who's written a line follower would know how this works. So that's a basic assumption I'm making while making this video, that you actually know how to write a line follower. So now what I'll do is I'll drag and drop an if and else statement. So I'll do a multiple comparison, because we are comparing two conditions. Sensor 1 is greater than 350. These are digital sensors, hopefully you're using. So greater, if you're using digital sensors which have an inbuilt LED, then these are the values which make sense. If you have older versions of the sensors, then you probably have to do the other way around. So I'm going to add more comparison. Yes, a double ampersand comparison, and that is sensor 1 is greater than 350 and sensor 2 is also greater than, let's assume, 350. That means both the sensors are right now pointing on the white surface. So which means that we have to keep on going forward. So what we need to do is motor direction, port 1, let's assume that motor port 1 is connected to M1, or the rear right hand side motor. So port 1 is clockwise and motor direction port 2 is anti-clockwise. So this means the robot is actually going to go forward. What is the next condition? Let's drag and drop if and else again. Let's open a multiple comparison. The next condition is sensor 1 is actually pointing on white, which means sensor 1 is greater than 350, and the sensor 2 is pointing on black, which means sensor 2 is less than 350. So in that scenario, if sensor 2 is pointing on black and sensor 1 is pointing on white, we want the robot to take a right turn. I'm sure you can visualize that. Okay, so I don't think we need to do this. No. Okay. So the condition here is sensor 1 is greater than 350 and sensor 2 is less than 350. That means sensor 2 is pointing on the black line, so we want it to turn right. So right turn is possible when both the sensors are actually, both the motors, sorry, motor 1 and motor 2 are in anti-clockwise direction. So let's do that. Port 2 is anti-clockwise, done. Now let's drag and drop another if else situation or if else condition. So in this one, the comparison is sensor 1 is actually pointing at black, which means less than constant, which is 350, and we have to add another condition, and sensor 2 is greater than constant, which is again 350. So condition is done. In this condition, we would want both the motors to go clockwise, or in other words, take a left turn. Port 1 is clockwise and port 2 is also clockwise. Once you have so now the final condition, that means our robot has actually come on top of this black patch. The two sensors are pointing at black. That means for the first time it has come on this black patch. That means there is a flag on the left hand side that you have to pick up. So in this particular robot, I'm not focusing on the mechanical design elements. I'm just focusing on the line following elements. So I'm just going to write a very quick function which is stop and go. But in the actual problem statement, you have to lift the flag as well. So what I'm going to do is write a quick function called stop and go to function, create a function called stop and go. Sorry. Once we have done that, return type is void, of course, create it. And what I'm doing is motor 1, port 1 is stop, and port 2 is also stop with some time control. And the time control is, let's assume we're stopping it for 500 milliseconds, and then we are going to make it go forward. Again, go back to motor direction. Port 1 is clockwise and port 2 is anti-clockwise, and we'll make it go forward for another 500 milliseconds. This you'll have to test how much is the right time for your robot to cross the black line. The second particular time duration was essentially to ensure that once your robot has come to this point, you have to make it go forward this black line also. Otherwise it will end up counting all the two blacks here itself. So that's why the second going forward is for the robot to go forward or cross this particular line. I've given it 500 milliseconds. You can choose your own timing, whatever you think is going to work. So with that said, stop and go is done. Now let's go back to the main function, main area here, and I'll do a quick if else. I'll do a quick if else, and I'll do a quick relational comparison here, which means counter. I'm going to count which particular black line it is at. So if counter is equal to 0, then what we need to do is I'm just going to call this particular function stop and go. I've done that, and I am going to increment the variable. Don't forget to increment the variable, otherwise it will always end up being in the first loop itself. So counter is equal to counter plus constant, which is 1. So you have incremented the counter. Now the next thing is you can bring in if else statement again, and what this particular if and else is going to do is do a relational comparison quickly. Counter is equal to constant, which is essentially 1. In that scenario, again, you have to, in the actual program you have to write a different thing, but for dummy what I've done is I'm putting stop and go again, and I'm going to increment the counter again. So variable arithmetic goes again further. I am incrementing the variable counter plus constant, which is 1, and computing it. Now the third statement where again dropping if and else. So if the counter is equal to 2 means it's encountering the third black line, which is essentially the drop area. In the actual robot I would write some logic where I can drop the radioactive debris, but in this one I'm just going to make it stop and go. So again drag and drop stop and go, again incremented the variable y1. So counter equals to counter plus constant 1, and finally this is the next. So now the assumption is I have crossed the first black patch, the second black patch, and third black patch. Now if it's the fourth time, which means that I have now come into the Mars area. So first black patch is the national flag, second black patch is the radioactive debris, third black patch is ISS, and the fourth black patch or two black value on the two sensors means I am in the Mars gravitational field. So now I have to change the program to turn it into a white line follower. So this is what I'm going to do. I am now going to write a quick function which is nothing but I'm going to call it WL follower, essentially a white line follower. So return type is again void. So what I do is again I almost like a line follow, write a line flow follower. So it's a loop. So constant double equals 1 is equal to 1, compare, and I will read the sensors again. So be careful, if you forget to read the sensors in the next function, then your program is not going to work. So I've read the sensor 1 and sensor 2 again, and I'm going to again drag and drop if and else situation conditions here. So the first condition is if sensor 1 is less than 350, which means sensor 1 is pointing at the black line or black surface, and sensor 2 is again less than 350. So I'll say no. So both sensor 1 and sensor 2 are on black line. Then what I would ask it to do is I will ask the robot to go forward. Motor direction. Port 1 is clockwise and port 2 is clockwise again. Oh, sorry, anti-clockwise. So it goes forward. The second condition is where sensor 1 is on white, which means it's greater than 350, and sensor 2 is on black, which means it's less than 350. So that means sensor 1 is on white and sensor 2 is on black. So that means we have to turn towards left. So what I'll do is I'll make both the motors move in clockwise direction because I want to take a left turn. Port 1 is clockwise, motor direction port 2 is again clockwise. Once that is done, then I will again drag and drop if else situation, if else condition. So here I will write the condition for sensor 1 is on black, that is sensor 1 is less than 350, ampersand or ending it with the condition where sensor 2 is actually on white. Sensor 2 is on white, so sensor 2 is greater than 350. And ending the program, done. So in that case what I want is my robot to take a, if my sensor 1 is on black and sensor 2 is on white, then my robot should be able to take a right turn, which means both the motors should be on anti-clockwise direction. So motion direction port 1 should be anti-clockwise and motor direction port 2 should be again anti-clockwise direction. And final situation where ideally what I would want to do is when it reaches the end, which is essentially it ends up reaching here, then it should stop, but before stop, just after stopping, it should hoist the flag here on the left hand from the left arm. But since I'm not writing that mechanism, or I'm not writing program for that mechanism, I'm just going to make the robot stop. So which means motor direction port 1 is stop and motor direction port 2 is also stop, and I will end the function here. We'll put the stop function end here. Now what I'll do is I'll call this WL follower in my last situation, or my last case, which is essentially over here. So when I encounter the blacks on both the sensor side for the fourth time, I wanted to change and start behaving like a white line follower. Just waiting. Okay, so white line follower, that's it. And I need to end the program here by dragging and dropping a stop. Save the program as, let's call it IRC senior 2015 solution. It's going to compile. Looks like there is an error in the program. This particular block is highlighted. Let's just see. This looks good to me. Sensor 1 is greater than 350. Okay, done. Okay, clear. So let me, it looks like there was some problem. So this one I'm going to say, just remember what the condition was. Let me just see. So this one was less than 350 and sensor 2 is greater than 350, so it has to be opposite. Sensor 1, okay, if sensor 1 is greater than 350 and sensor 2 is less than 350, this looks good. Cancel. I don't want to change it, and let me save it once, and it's good to go. So hopefully this is compiled successfully, and I can just go ahead and burn on the robot that I made, and I'll show you that output as well. Thank you.